In this project, we want to perform a basic differencing attack to divulge what the value is in a database, specifically the value on row 10. Now, the way we're going to do this is we're going to perform two different queries against the database. One, which is a query that includes row 10, and then we're going to perform a query against the database excluding row 10. And the idea is we want to be able to compare these two different queries and determine what the exact value of row 10 actually is. So the first thing we want to do is initialize a database. We'll put 100 values in it. And then we want to initialize a parallel database, meaning a database with just row 10 missing. So this is the same as doing a SQL query where it's like, select, some function where database value does not equal, and then, the index of a specific number, right? So if for example, in this database, if every person was associated with Bob, now we're saying, okay, run this query where name does not equal Bob, right? That's what this one's going to be. So this is the whole database, this is the database with one person missing. So parallel database will be get parallel database from the database when we're going to remove index 10. Cool. All right, so let's see what's the truth thing we're trying to divulge. Okay, so there's a 1 here, right? But we're going to try to sort of learn that there's a 1 here by virtue of the fact that we're doing multiple queries against these two databases. So the simplest one we can do is just a sum. So the sum of the database minus sum of the parallel database. This will divulge the exact value, right? So as you can see, it equals 1. And if this had equaled 0, this would equal 0. Maybe we can try that out in a second. So this is differencing attack using addition, using a sum query. We can do the same thing with a mean query, but all we do is we just divide by the length of the DB. Technically, the auto operations means we don't have to do this, but got it cast to a float. Cool. So as you can see, that's non-zero, so we know this is indeed a 1 because of the database of 1s and 0s. And then, of course, we can do a differencing attack using a threshold query. So for this one, we can base it off this one, I think. And really what we're going to do is we're going to say, is this greater than, so what was the actual sum? 50. So this is 49. So this will return true because the sum over the database is actually equal to 50, so this will be true, but this one will be false, right? So when we actually adjust it, greater than 49, right? So this one will return true, this one will return false, and the difference between the two will be 1. So as you can see, using these three different attacks, they're all sort of doing the same thing, right? They're performing a query with a value that's missing. And as you should be familiar with at this point, given the intuitions around differential privacy that we've been formulating, this differencing attack is very close to the heart of the intuitions behind differential privacy. And so as we form differentially private techniques, we want them to specifically be immune to these kinds of attacks. And as we'll see in the formal definition of differential privacy, this is very, very close to this is a constraint we must satisfy in order to satisfy differential privacy to a certain threshold. See you in the next lesson.